right, so let's take a look at section 2.4. Okay, yesterday, 2.3, we solved equations. Okay, today we're going to look at inequalities. Okay, the only difference between an equation and inequality is the symbol that you put in the expression. Okay, what are, does anybody remember the 4 inequality symbols? Yep.
Greater than, or equal to, and less than, and equal to.
Yeah, so those are your 4 inequality symbols. Okay, the order I have them, less than or equal to, greater than or equal to. Okay, these are both examples of inequalities. Okay, the one on the left is a true statement. 3 is less than 8. Just a true inequality. The one on the right could be true, depending on what you let x be. Does anybody remember what that's called? We did this with equations. It can be true if you pick the right values for x.
Conditional.
Yeah, if you had conditional equation, that's a conditional inequality. Okay, in this case, you've got to pick values of x that are greater than 4 to make it true. Okay, what's different about an inequality is there's infinitely many solutions. If I write this, there's one answer. 3 times 4 gives me 12. 4 is the only number. Here, 3 times what is bigger than 12? Well, there's infinitely many. 3 times 5 is bigger than 12. 3 times 6.5 is bigger than 12. Any number that's bigger than 4. All right, so the way we check if a number is a solution is you plug it back in and see if you get a true statement. All right, so let's just try this one. Let's let x equal 2. Okay, if I do that, I would get 3 times 2 is greater than 12. Is that true? No. All right, so 2 is not a solution to this problem. Not true. Okay, let's let x equal 5. Now I get 3 times 5 is greater than 12. Is that true? Yeah. So 5 is one of the solutions to this problem. Okay, that's how you check if a number is a solution. Okay, any question on that? All right. If you take 2 inequalities and you connect them with the word and, that's called a conjunction. And that's an example of a conjunction. X is greater than -1 and x is less than 3. Okay, a lot of times conjunctions are like between statements. Okay, you could pick any number here between -1 and 3, and it would satisfy what I've written on the board. Could you actually pick -1 or 3? And it would satisfy what I have here? No. Why not? It's not equal to. You have to pick something that's less than 3 and greater than -1. Okay, a lot of times when we write a conjunction, we don't write it separate. Okay, we can combine it all together just like that. Right, and basically, if you look at that, here's one of the inequalities. Okay, kind of in a different order. X is greater than -1. It's pointing at the -1, just like it was up above. And here's your other one right here. X is less than 3. Any questions on how you take 2 separate statements and combine them into a single statement for a conjunction? Again, it's more of an Algebra 1 thing, but we're going to use it, so I just want to make sure people remember that. Okay, the answers here, or the range of numbers between -1 and 3, that's called an interval. Specifically, this is called an open interval. And I'm going to go through 4 different types of intervals right now. Okay, and I'll explain what an open interval means. All right, the types of intervals we're going to look at right now are what we call bounded. Okay, a bounded interval means that at the end of each interval, you have a number, like we do here, from -1 to +3. Those are my bounds, and they're numbers. Okay, sometimes you have a bound that's not a number, like infinity. Okay, if I said to you, here's an inequality, x is greater than 4. There's no upper limit on that. Just, it goes on forever. Right? That's an unbounded interval. Okay, here there's an upper limit. 3 is as high as you can go. -1 is as low as you can go. Right, so a bounded interval has numbers. Right, so first kind of interval you can have is what's called a closed interval, and it's closed on each end. Okay, what closed basically is equivalent to is you can equal the number. Right, so when you see the bracket, you can think all numbers between a and b, and the bracket means you can equal a and you can equal b. The example we have up above, this is an open interval. Means you can pick all numbers between a and b, but the parenthesis means that you cannot equal a and you cannot equal b. So it would be like if you had less thans and greater thans. Okay, that's when we'd use parentheses to describe it. If you have less thans or equal to, greater than or equal to, that's when you use the bracket. All right, so I said there's 4 types. We've got closed on each end, open on each end. What other type do you think you could have? Yeah, you could have kind of like half open or half closed, depending on if you're optimistic or pessimistic. Okay, so we'll go with half open. Right, this one is half open on the right. This one is half open on the left. Those are all the different kinds of bounded intervals you have. When you have an interval that's half open, either on the left or the right, that means one of your inequalities has the equal to, one of them doesn't. And page 99's got more examples you can look at with actual numbers. Okay, so any questions on what it means for an interval to be bounded and then open or closed? All right, we're gonna practice writing some of these. Okay, the other kind of interval you can have is unbounded. Okay, an unbounded interval uses -infinity or +infinity. Okay, these are all examples of unbounded intervals. Anytime you use infinity or -infinity, always put a parenthesis on it. Why? Because you can never reach it. Okay, when you put a bracket, that means you can include it, you can reach it. Okay, but infinity you can't reach. All right, so this first one in the upper left, this is saying all numbers from -infinity up to and including +3. The one below it is saying all numbers from -infinity up to 3, not including 3. So you can go up to like 2.9, repeating. Okay, on the top right one, this is saying all numbers from 5 to infinity, including 5. The one below it is all numbers from 5 to infinity, not including 5. So like 5.000001 and on. Right, so these are unbounded because they use infinity. And those are the 4 types of unbounded intervals, and I put them right here for you. All right, let's try kind of translating between writing something as an interval and an inequality. All right, so I want to write this as an inequality. Okay, so I start with x in the middle. And this is a half open, half closed, so I'm going to be using one of each symbol. Anybody think they can tell me what number goes on the left? Yep, the -3. And how about How about on the right? 5. Okay. What symbol am I going to put between -3 and x? Which one, Jamie? Yeah, we're going to put a less than. And how about between x and 5? All right, here's a hint. When you write an inequality like this, both of them have to point the same way. Less than or equal to. Yeah. You can't have one pointing one way and one pointing the other. All right, so this says you can pick all numbers that are greater than -3, and the number also has to be less than or equal to 5. These two are exactly the same thing. Interval notation, inequality. Questions on that? Is this a bounded interval or unbounded? Well, the half part, that gets into the open and closed. This is bounded. Okay, bounded because there's a number on each end. Okay, how would I write this as an inequality? I can pick any number from -4, including -4, up to infinity. This one's actually a little shorter. It's a little simpler than this. Yep.
Can you just do -4 is less than or equal to x?
Yep, you could say it this way. Or how else could you say it? Whoopie? Greater than or equal to? And how would you write the whole thing? Okay, how else could you rewrite this? Because we usually put the letter on the left. Yeah.
X is greater than or equal to -4.
Yes. Okay, what this says is you can pick any number from -4 to infinity. So anything that's greater than or equal to -4. Okay, this is fine too. It's not wrong. Just we usually put the letter on the left, especially when we start graphing them. If you put the letter on the left, the inequality tells you which way to shade. If you don't do that, then this tells you the opposite way to shade. Is this bounded or unbounded?
Unbounded.
Unbounded. Is it open or closed?
Half open.
Half open. This is half open on the right. Okay, and last interval. Okay, -8 to -3, including both. Eric, could you tell me how I write that one as a inequality?
-8 is less than less than equal to -3.
Like that? Well, look at your inequality symbol, right?
Yeah.
And then take a look at these symbols. Are these symbols the same?
Yeah.
Yeah, so then these symbols should be the same. You want,
So it's just less than, not equal to.
which one do we use for the bracket? Is that the equal to or without the equal to?
Without it.
With the equal to. The bracket is with the equal to, right? So when you have a bracket, you use the equal to. When you have a parenthesis, you don't use the equal to. Okay. Any questions on that? That's important. Okay. This interval, bounded or unbounded?
Bounded.
Unbounded?
I'm sorry, bounded.
Bounded. Okay, you have a number on each end. Okay. Open or closed? Closed. Completely closed. Closed on each end. Yeah.
Is the bracket always going to mean that it's less than or equal to?
Yes. Or it could be. Some people might write their inequality the other way. This is also correct. Nobody said this, so I didn't bring it up. But you could say x has to be less than. X is less than or equal to -3, and x is greater than or equal to -8. That same thing. It's just like what Justin did earlier, switching it around. Okay. I generally always do the less thans, but that's also fine. Okay. Other questions? All right. Let's try doing a couple graphs. Okay, most books, like especially in Algebra 1, the book we use here, when you go on a graph this, they use an open circle or a closed circle. Right? If you want to do it that way, that's fine. Okay, but I kind of want to get in the habit of using the symbol our book uses, which is either a bracket or a parenthesis. Use a bracket with the equal to, that's like your closed circle, and use a parenthesis when you have something like in example B. Okay? That would be like your open circle from Algebra 1. All right, so first thing I got to do is draw my number line. Okay, on a test, I'd have one for you. Okay, number it. And what kind of symbol do I put on 2? Would I put a bracket or a parenthesis? Yeah, we're going to put a bracket. Now, the thing with the bracket is it can face either way. So now we got to look at which way am I going to shade if I want numbers bigger than 2.
To the right.
Yeah, we're going to shade to the right. So put a bracket and shade right. In Algebra 1, you probably would have done something like this. Same thing. Same exact thing. Okay. How about x is less than 5? Cameron, can you tell me what kind of symbol? Bracket or parenthesis?
Parenthesis.
Yep, you need a parenthesis. So let's set this up. And Cameron, which way do I shade if I want all the numbers that are smaller than 5?
To the left.
To the left, yep. So parenthesis, shade left. Okay, question on that? Right, and example C. Okay, this time I'm going to need 2 symbols. Okay, let's go -1, 2, 3. Joe, what kind of symbol am I going to put on -1?
Bracket.
Bracket. Okay, just going to put a bracket on -1. And how about what kind of symbol on 3?
Parentheses.
That's a parenthesis. And where do I shade if I want all the numbers that are bigger than -1 but smaller than 3? Jamie? Yeah, we're going to shade between. And that's it. Right, so questions on how to take an inequality and graph it, especially with the bracket and parenthesis, because I'm going to guess that symbol is probably new for a lot of people. Okay. All right, so when we're solving an inequality, you do it just like you're solving an equation, except there's one thing that can happen. Does anyone remember what can happen when you solve an inequality with the sign?
You might have to change the sign.
You might have to flip it. Somebody else tell me, when would you have to flip it?
When it's negative.
When do you have to flip an inequality? Yeah?
Take an X on the left side.
All right, we might have to flip it if you want to rearrange it, just to get the x on the left side. But the flipping I'm thinking of here is when you multiply or divide by something special. Yeah?
Negative.
By a negative.
Negative.
Okay, if you multiply or divide each side by a negative, you have to flip the inequality. Okay, if you don't, then it comes out wrong. Okay, so make sure you remember that. If you multiply or divide each side of an inequality by a negative, flip the inequality. Right, sometimes, depending on how you solve it, you can kind of avoid doing that. It depends on how you solve it. All right, so Tyler, what's my first step to solve this?
I do 3 times x and 3 times -1.
Yeah, we'll just distribute that 3 out. And can you tell me what I get when I do that?
3x minus 3.
Perfect. 3x minus 3 plus 2 less than or equal to 5x plus 6. Okay, we don't flip anything here. We didn't do anything to both sides even. All we did was distribute a 3. Right. Tyler, what would be my next step on the left?
You have to combine the terms.
Yeah, we got to combine these like terms. Yep, -1. So 3x minus 1 is less than or equal to 5x plus 6. Now we're going to start moving stuff from side to side. Dalton, let's move the x's. Do you want to put all the x's on the right, or do you want to put them on the left? Okay. How would you put all the x's on the left? What would you do? Subtract 5x. And 3x minus 5x leaves me with negative. What are we doing here? We're subtracting, right?
Are we divided?
No. Subtract. Oh, sorry. Did you say divide?
Yeah.
No, it's subtract.
All right.
Yeah. Because you got to, the only time you're going to divide is when you have a number next to a letter.
All right, so then it would be
Negative 2x. Yeah. Right, so to get rid of this negative 2, eventually we'll divide, but not yet. Nick, what's my next step?
Add 1.
Yep, add 1. And what does that leave me with?
7, negative 2x is less than or equal to 7.
Less than or equal to 7. Now, should I be flipping this inequality? Have I done any multiplying or dividing by a negative yet?
Not yet.
Not yet. Okay, but what's my last step? Divide by negative 2. Okay, 2's are gone, negatives are gone. And I get x. On the other side, I get negative 7/2. What about the inequality? Flip it or leave it alone? Flip it. People always forget it. You always forget if you multiply or divide by a negative to flip it, but try not to forget. Any questions on that one? Okay, how could you have avoided this having to flip it? There's something we could have done back at this step. Instead of doing something, we could have done something different.
You could have just made x be on the right side.
Yeah, we could have just put the x's on the right and put all the numbers without x's on the left. Okay, and we could have avoided that negative. Right? And if you did that, your final answer would have looked like this. Let's see. It's the same thing. It's exactly the same thing. Okay, this is definitely the preferred way because if you do it that way, you want to graph it. This tells you which way to shade because the letter's already on the left. All right, so let's look at how we can use the calculator to solve some of these. Calculator is helpful if the inequalities start to get really complicated. Okay, and algebra seems a little tricky. Okay, and there's 2 ways you can do it. Okay, the first method to use your graphing calculator, do it just like you were going to solve a quadratic equation. Get 0 by itself on one side. Once you get 0 by itself, then you're going to calculate a root. And then, depending on what the problem says, it's either going to say find where something is greater than 0, or where something was less than 0, or greater than or equal or less than or equal. That depends on the problem. All right, so let's try this one. 4x minus 1 is less than 2. Okay, using method 1, first thing I got to do, I got to get 0 by itself on one side. So, Will, how would I do that? How would I get 0 by itself on one side?
Minus 2.
Yeah, just minus 2 from each side. Now I'm subtracting. That's a negative. Should I flip it?
No.
No, I'm not dividing. I'm subtracting. So 4x minus 3 is less than 0. Right, now we're going to graph it. Okay, so on your calculator, type in y1, 4x minus 3. Okay, if you've got a different window, I would just do zoom 6, get the standard window. And this time we're looking for where the graph is below 0. Where is it less than 0? Okay, so take a look at it. Okay, so the graph is less than 0 in this section right here. I just colored in red. So what I have to do is find this point. And it's every value from this x value down to the left. All right, so let's calculate that root. Okay, so pick a point to the left. Pick a point right. Do your guess, and it's 0.75. Okay, so if you pick any number less than 0.75, the y value will be below 0. Yep.
When you do that, you do second intersect, right?
Nope, you use root or 0. Yep, second option down. Intersect is only for finding where two graphs cross.
All right, yeah, 'cause my calculus was like first curve, second curve.
Yep, that's for intersect. Yep. Okay. Unless I draw a line, I mean, now if I did something like this, now I could do intersect. See how I just put that line in on the x-axis? Now I could do what you were doing. Yeah. That's an extra step. Okay. Any questions on how I got x is less than 0.75? All right. So that's method 1. Okay, method 2 is don't rearrange it. Don't get 0 on one side. Leave it the way it is. Basically, take what's on the left, put that in y1. Take what's on the right, put that in y2. And now we can use an intersect, because we're graphing two separate things. And then once you find that intersect value, you're either going to want x's above that or below that. Depends on the inequality in the original problem. All right, so let's graph the same. We'll do the same one again. Okay, we already know what we should get. X is less than 0.75. Okay, but let's do it this way. Okay, so put 4x minus 1 in y1. Put 2 in y2. And we're looking for where 4x minus 1, which is the blue line, where that's below the red line. Okay, we want to find where the blue line is below the red. Okay, so hit graph. There's blue. There's red. All right, so let's just look at that. So what we want to find is this section right here. Find that point, and it's every value to the left of that. Okay, so now you can do second calc. Intersect, first curve, second curve, do your guess, and we get the same thing. X is less than 0.75. Okay, questions on doing it this way? Yep.
Can you move the graph?
Can I move the graph? Yeah, is there something under there? No.
No.
Yeah. That's it. Right, so which method you want to use, method 1 or method 2? It's up to you. Yeah, I think if 0 is already on one side by itself, I would use method 1. If 0 isn't on one side, maybe I don't want to spend the time rearranging it. Just use method 2. But either method will work. Okay, so any questions on either method 1 or method 2? We're just going to practice a few more examples graphing those and using either one of these methods. Yep.
When you find the intercept, what do you mean by you put the curve?
Oh, the curve?
Yeah.
So when you do intersect, it's going to ask you, what's the first curve? So like if you had, say, multiple lines on this, there might be intersections all over the place. You have to tell it which two you want to find the intersect for. In our case, there's only two on the screen. So this is kind of pointless. But if I had something like this, now I got to tell it, well, do you want to find the intersection between the pink and the blue or the blue and the red? Which curves do you want to intersect? Okay, so in my case, I was doing the blue and the red. So now it knows which two to look for. And then the guess, again, for this one, the guess isn't really important because there's only one intersection between the blue and the red. But let's say you had something like this. Okay, here's your blue line. Here's we'll do a green line. Now if I was doing an intersect, whichever guess I was closer to, it would give me the different intersection point. I'd have to put the guess closer to the one that I want. Okay, any other questions on that? All right. Right, so double inequalities, especially, these are really, calculators really useful to graph these sometimes. But algebraically, basically, it's the same goal, get x by itself, except x is in the middle. Right? So whatever you do to the middle, you do to the left, and you do to the right. It's like in this problem, you divide everything by 2, and that'd be it, to get x by itself. I don't think we're going to have time to graph a double inequality today, so we'll solve it algebraically. And if we need to do one from the homework, we can graph one tomorrow. Okay, what would my first step be here to try to start getting x by itself? Yeah.
Divide by 3.
So right now we have 2x plus 5 divided by 3 in the middle. First thing you want to do is get rid of that divide by 3. Derek? Multiply by 3. Yeah. Okay, when I multiply by 3, takes care of that. Same rules apply if you multiply or divide by a negative. Flip everything. Okay, but that 3 is positive. So negative 9 is less than 2x plus 5. Which is less than or equal to 15. Tyler, what's my next step?
Would you subtract 5?
Yep. Subtract 5 from everything. Those are gone. Okay, we have negative 9 minus 5. Gives me negative 14. Is less than 2x. Less than or equal to 10. Subtraction, don't ever flip the sign for that. And Matt, what would be my last step?
Divide by 2.
Yeah, divide everything by 2. Right, so on the left, we're going to get negative 7. On the right, positive 5. That's it. That's a double inequality, which I could have done graphing. I could graph the left in y1, graph the middle in y2, graph the white in y3, and then I'm looking for where something is sandwiched between two other things. I don't think we need to look at that right now. I think this is the last thing before we just do some more graphs. Okay, graphing, or even solving algebraically, absolute value inequalities. Okay, pretty much the same as we did yesterday with absolute value equations. Okay, you're going to take the original problem and split it into 2. In fact, the first step is exactly the same as what we did yesterday. take the original problem, copy it down, just take out the bars. Okay? That's one of the problems you're going to solve. Okay. Now, yesterday for the second one, we copied down the original problem, we removed the bars, and what was the extra thing we had to do?
Make one positive and one negative.
Yeah, you got to make the other side negative. Right? But with an inequality, if you make something negative, you have to flip the sign. Okay, so that's the extra step today. For the second inequality, copy down the original, take away the bars. You're still going to make the number on the other side negative, or positive if it already was negative. Change the sign of it. But if you change the sign, you've got to flip the inequality. Okay, that's the extra step. Okay, any questions on how to set up the two problems we're going to solve? Okay, we'll try one example. All right, and then when we write our final answer, we have two choices. Okay, for our final answer, it's either going to be something and something. What's the other word we use a lot of times with inequalities besides and? Or. Right, so we have two choices. We're either going to use the word and in the final answer. We could use the word or. Okay, this is how you know when to use and. Look at the original problem. If the original problem has a less than, or a less than or equal to, we use and. Okay, some books use the symbol intersect. All right, the reason they use the term intersect, think of like a Venn diagram. If I said, I want you to shade in what's in A and B, well, that's where they intersect. It's right here. That's A and B. It's where they overlap. So that's where that term comes from. It's where they intersect. Okay. If the original problem has the other two symbols, greater than or equal to, that's when we use or. Okay. And the symbol for that is a U shape. Okay. You might see that in our book. It's called a union. All right, so let's try to solve this one. And as far as the graph, we're not going to graph it on the calculator. Maybe we'll do it on a number line real quick. So then we can just try maybe one more, two more on the calculator. I think this will be the last one we do with algebra. All right, so step one, okay? Make sure you get the absolute value by itself. So if you had something like this, first thing you'd want to do is subtract 1, bring it to the other side. Okay. I tried to make this one a little easier. I already got it by itself. All right. Next step. Split it into two problems. Okay. First one. Copy down the original problem. Just take out the bars. X minus 3 is less than 3. That's the first one. How about my second one? All right, there's three things you got to do on the second one. Take out the bars, make the number negative, flip the sign. So what would be my second one? Yep.
Minus 3 greater than 3.
X minus 3 is greater than
Negative 3.
-3. So he took out the bars, he flipped the sign, made the number negative, did all three. Perfect. And now look at the original problem. It had a less than. Is that an and? Or do we use or?
Or it hadn't. It wasn't.
Yeah, always go back to the very original problem. It was a less than. Use and. Okay. Sometimes the way I try to help people remember that, less than is and. So if you can remember the word land, less than is and, land. I don't know if that helps, but Okay. All right. Oh, Fernando, how do I solve this?
X by itself.
Yep, get x by itself.
Plus 3 on both sides.
Yeah, it's plus 3 on both sides. So x is less than 6. And, same step again, plus 3 on both sides. X is greater than 0. So in other words, numbers between 0 and 6 make this true. Okay, so if you want to write your answer like this, go ahead. That's the shorter way to write it. X is greater than 0, but also less than 6. Questions on that one? Yeah.
What absolute values did they like had to be positive? So like how is it an absolute value of x minus 3 still going to be x minus 3?
I'm not. Are you looking at this side or are you looking at this side?
Left side.
The left side?
Yeah.
How could x minus 3 come out to be less than 3?
No, because it's the absolute value of x minus 3. So it's going to be x plus 3.
No. Should be minus. Let's just try it. Let's try a couple numbers and see if they work. Let's try like a number between 0 and 6. Let's try 4. 4 minus 1 gives me 3. No, yeah. 4 minus 3 gives me 1. Absolute value of 1. 1 is less than 3. Is that true?
Yeah.
Yeah, so it works. Let's try like, we can't do negatives. Let's try 1. 1 minus 3 is negative 2. Absolute value is positive 2. Is 2 less than 3? Yeah. So it does work. That's just how you do it. Yeah. Now, the only time you'd have a plus here is if you had a plus here and a plus there. That would make everything pluses. All right, so just try a couple graphs. These are all just on the calculator. Might be good just to make sure, remember how we do absolute value. Okay. Does anyone remember where that is? Yep, it's under math. And where do I go after math? Yep, under number. Okay, first option is ABS. Okay, pick that, absolute value. Okay, now I have two choices the way I could do this. I could use method 1, which is to get everything on one side and get 0 on the other, or just leave it the way it is. Put what's on the left in y1, put what's on the right in y2, and the colors are going to make this easy to see. You're looking for where the blue graph is above the red graph. Okay, that's what we're looking for. Where is the blue graph above red? Okay, so say graph, there's the blue, there's the red. All right, and let's make that a little bigger and look at it. So there's a couple places. Okay, first thing we need to find is both of those points. Okay, if I pick anything to the left of that first green dot, it'll be above the red. If I pick anything to the right, it'll be above the red. The only thing I can't do is pick values between the green dots. If I do, I'm going to go below the red. All right, so let's find what those 2 points are. Okay, we're trying to find where 2 lines cross. That's an intersect. So pick a point on the first curve, second curve, and put the guess closer to whichever one you want to find first. Okay, point 3 repeating, or 1/3. All right, so in this case, we've got x is, let's see, let's go back and look at it, less than or equal to 0.33. All right, and what else could we have? Let's look at the other one. Anybody find the other intersection point? It's 1? All right. So you could pick anything less than 0.33, or you could pick anything greater than or equal to 1. Okay, as an interval, you could write it like this. Pick anything from negative infinity all the way up to 0.33, and you can include it, or, that's that union symbol, or pick any number from 1, and you can go as high as you want. 1 to infinity. Okay. These are exactly the same thing. Right, so we're not going to do that one algebraically. And notice, I'll just move this example down. We use the word or. Probably should have pointed this out. Look at the original symbol. Greater than. Greater than is an or. Okay. All right. Let's see if we can look at this one. Is that the same one? No, a little different. Does anyone need me to go through this one? It'd be the same idea, except would this be an and or an or? This one would be an and. Okay, so you'd graph it just like we did, and you do the same idea. Let's try this one. This will be our last one. Right, what I would do, since 0 is already by itself on one side, just leave it like that. So we're going to do this one with 0 by itself. Okay, in parentheses, put x plus 3 divided by, put in absolute value, x minus 2. And we're going to look for where this graph is positive. Look for where it's above 0. All right, let's look at that. Here's your graph. So at some point right about here, it crosses and it goes above 0. Is there any value here we'd have to be careful that you could not use for x? Actually, -2 I think is okay. That's right on the graph. Yeah, +2. What's happening at +2? Let's look at it on the table. Error. Why can't I use +2? What's going on there?
It's divided by 0.
It would be dividing by 0. Right, so we can pick any number from here all the way up to, that's just going to keep going, right up to +2, but you can't include it. All right, so let's find that point, because that's where we go above 0. So I'm going to calculate a root. Pick a point to the left, go to the right, take a guess. All right, it's -3. Can we include it? No. This symbol says not to include it. So you can pick any number from -3 up to 2, and that'll give you this section right here. And that just keeps going. Now, is this graph positive? Is it above the x-axis anywhere else? Well, Brian, what do you think?
To the right of 2?
Yeah, it's positive over here. Okay. The only question is, does it ever come back down below like it does over here? All right, so what I would do is just go to my table, and look at what happens as you let x get really big. Let's go all the way out to 50. Did it go below 0 at 50? No, not yet. Let's try 500. Did it go below 0 yet? Nope. Let's try like 10,000. Did it go below 0?
No.
No. If I've gone all the way out to 10,000 and it's still above 0, it's probably never going to go back below 0. In fact, it's probably never going to go below what number? 1. It looks like it's getting very close to it, but it looks like it's not going to reach it. All right. So we can pick any number from -3 to 2, or from 2, how high can I go? Infinity. As high as I want. Okay. So there's your answer as an interval. Right, so anytime you get stuck doing it algebraically, try graphing it and see if that helps. Or if you're stuck on the graph, try using algebra. All right. So the homework tonight it's on 108. Okay, it kind of skips around a little bit. We've got 5 through 7, 10 and 11, 14 through 16, and then a bunch of single problems, 25, 26, 29, 34, 35, 42, 43, 49, and 60 to 62. Some of these are just graphing on the calculator, so there's nothing to show on the paper. Just write that you did it on the calculator. Right, and we'll take a look at that first thing tomorrow.